Hello everyone. Today we are going to understand about automaticity of SN node. SN node is able to produce impulses on its own. It does not require any external stimulus, and therefore it is also called as natural pacemaker of heart. Today in this session we will be dealing with how the automaticity of SN node is maintained through this graph. This graph represents the electrical activities in SN node. Let's assume that this is SN node. In SN node, there is the presence of some special channels. These channels are called as SCN channels, where SCN stands for hyperpolarization activated cyclic nucleotide channels. So whenever there will be hyperpolarization, these channels will open and there will be sodium influx. Sodium will accumulate within SN node. Accumulation of positive charge will obviously depolarize the SN node. Okay, let's understand this from the graph itself, and then we will list the points step by step. If we see this graph, the red line here represents the electrical activities in SN node. Whenever the potential of SN node reaches minus 60 millivolt, that is this level, this is called as the hyperpolarization, and the SCN channel will open up. Sodium influx occurs in the SN node and then the depolarization begin. So sodium influx actually leads to this depolarization. Slowly and slowly the potential of SN node from minus 60 millivolt to minus 55 millivolt to minus 45 millivolt, and finally it will reach up to minus 40 millivolt. And this minus 40 millivolt is regarded as the threshold potential for SN node. Whenever this threshold potential is reached, then the voltage gated calcium channels open and there occurs calcium influx. This calcium influx leads to rapid depolarization. So this stage is the depolarization stage. Once it reaches the peak, then the voltage gated calcium channels close. And now the leaky potassium channels open up and potassium efflux occurs, which leads to again repolarization. Slowly and slowly it will again leads to the membrane potential of SN node to minus 60 millivolt. Once minus 60 millivolt potential is reached, again there occurs the activation of these SCN channels, and again sodium influx occurs. Again depolarization begins. Threshold is reached, voltage gated calcium channels opens up, depolarization occurs, and then again potassium efflux occurs and repolarization is reached. These cycles repeats and repeat throughout the life. In this whole electrical activities, one thing we can notice is that there is no actual resting membrane potential in SN node, and even there is no involvement of any external stimulus. It is itself getting hyperpolarized, depolarized, the action potential is developing, again repolarization is happening. So this all leads to its automaticity. The main feature which is contributing for its automaticity is this part, that is the opening of SCN channel. Because of these SCN channels, Slowly and slowly, the membrane potential is reaching towards the threshold potential for the depolarization of SA node. And the opening of SCN channel is producing a current that is called as funny current. So this portion is considered as funny current, which is responsible for SA node. Now let's compare this graph of SA node with the graph of ventricular muscle fiber. Why the SA node is able to produce impulse on its own, but the ventricular muscle fibers is not able to produce on its own, and it is dependent on the external stimulus for its depolarization. The red line represents the SA nodal activities, while the green line represents the ventricular muscle fiber activity. So this is for SA node, while this green line represents ventricle muscle fiber. Let's understand the difference in between these two graphs. Here there is the presence of this funny current in SA node, which is absent in ventricle muscle fiber. There is no slope in this graph. Instead, there is resting membrane potential in ventricular muscle fiber, which is absent in SN node. So in ventricular muscle fiber, there is a resting membrane potential, and this resting membrane potential makes the ventricular muscle fiber stable. So without any external stimulus, it cannot depolarize. Here the stimulus is required for its depolarization, and this stimulus is none other than the impulse from the SN node, which travels through the AV node, through the bundle branch, Purkinje fibers, and finally into the ventricle muscle fibers and stimulate it. So this is the impulse from SN node itself, which acts as a stimulus for the ventricular muscle fiber depolarization. From this comparative graph, we can understand that this funny current is what is leading to the automaticity of SA node. It does not require any external stimulus. There is no any resting membrane potential for the SN node, and therefore it beats on its own. Okay, let's summarize these all points step by step. First occurs hyperpolarization. When membrane potential of SN node reaches minus 60 millivolt, then SCN channels open. This leads to sodium influx. Sodium influx leads to the production of funny current. Then after the membrane potential reaches to minus 40 millivolt, which is actually the threshold potential of SN node. Once the threshold potential is crossed, there occurs rapid calcium influx through the voltage gated calcium channel. and it will lead to depolarization or action potential of the SA node. After that, the calcium channels close and the leaky potassium channels open, which will lead to potassium efflux, and this leads to hyperpolarization once again, and the cycle goes on repeating. And this way, automaticity of SN node is maintained. If we summarize this all in a nutshell, the automaticity of SN node is maintained due to funny current, and this funny current is produced due to the presence of SCN channels, and these SCN channels are highly concentrated in SN node, and therefore the SN node is able to produce impulses on its own without any external stimulus. Hope this finds fruitful for you. So this is all about the automaticity of SN node. Thank you.